Hi guys, in the last video I have explained about the assembly line scheduling problem. So let's continue that. So this will be the input, for example. So input will be given like this in the form of array. Okay, 2D array. So I will mention the number of stations as 4. So there is one more station added now, polishing station. Okay, so you can fit the car from, okay, and the entry cost is given as 10. Okay, this is the entry cost array. So entry for line 0 is 10, entry for line 1 is 12, exit for line 0 is 18, exit for line 1 is 7. Okay, so these are the two things. And now in this A array we are mentioning what is the cost at that particular station. So this is 0 comma 0. Okay, so this is the cost 4 is the cost at first station in the line 0. Okay, so 5 is the cost at second station in the line 0. Okay, I just made the things according to the array indexes. Okay, array starts from 0 to n minus 1. Okay, so this is 0 comma 0, and this is for 5, this is for 0 comma 1, this is for 0 comma 2, and this is for 0 comma 3. So this is the cost at this particular station. It costs 4 units, it costs 5 units, it costs 3 units, this cost 2 units, and this is for 2, 10, 1, 4. Okay, respectively. Okay, at this station, at first station in the line 1, it costs 2 units, here it costs 10 units, here it costs 1 unit, and here it costs 4 units. And T, okay, there is one more input T. Okay, this is a 2D array, and this gives the transfer cost. Okay, this is 0 comma 1. So from line 0, if you are transferring the job to first station in the second line, okay, the cost is 7 units. Okay, this is for 0 comma 2. If you are transferring the job from line 0 to third station, it cost 4 units. And this is if you are transferring the job from third station to fourth station, okay, 0 to 0 comma 3, from line 0 you are passing the job to fourth station. Okay, array concept. Okay, 3 plus 1, 4, fourth station, from 0 to 4. Okay, just add 1 to this index, you will get to which station you are passing the job. Okay, and the first index represents the on which line the job is. Okay, 0 represents job is on 0th line. 1 means 1 plus 1, 2. So you are passing the job from here to second station, you are passing the job from here to third station, you are passing the job from here to fourth station. Okay, in the same way, 1 comma 1 represents you are passing the job from here to here. Okay, and 1 comma 2 represents you are passing the job from S11 to S02, and this 1 comma 3, this represents you are passing the job from S12 to S03. So this is the input, and now we have to write a recursive function. Okay, as I explained, car enters here. At every station there is some job being done, and there is some cost associated with it. Okay, there is no cost if you are passing the car in the same line continuously. There is no cost. If and only if you are passing from one line to another line, there is a transfer cost associated with it that I have mentioned. Okay, there is an entry cost and there is an exit cost. So we have to find a minimum cost. Okay, we have to find in which path. Okay, there are multiple paths now. You can go straight line now like this. You can enter here, you go straight line and exit here. You can enter here, you can go here, you can go back, and you can come back and exit like this. Okay, you can go straight, okay, and do the polishing in the line 1 and exit. Okay, you can go straight till body fitting, you can transfer to painting, and you can come back to polishing and exit. So n number of ways. So you have to enumerate all the ways. Okay, you have to calculate the entire way. So from starting till ending, it will calculate the cost. Okay, in each and every path you have to calculate the cost. Once you calculate the cost, you have to return the minimum. So for all the paths you will have some cost. Out of all the cost you have to return the minimum cost. Okay, let's write the recursive function. So this is the input. Okay, I am defining hash define stations as 4. There are 4 stations over here now, and I am, as shown in the diagram, this is the input. Okay, now let's evaluate the options. So whenever there are 2 lines over here, you can enter from line 1 and you can enter from line 2. Okay, you enter like this. Okay, from line 0 you enter, you continue the job like this, and you can switch the jobs between the lines internally. Okay, you can switch the jobs. So you do the job here, you can switch to line 1, you come back to line 0, like that. Okay, but there are 2 lines here. Okay, you have to find the minimum cost. So entry cost might also differ. So when you are entering the line 0, the cost is 10, very minimum. But when you are entering from line 1, the cost is high, 12. Okay, so this shows that by passing from line 0, the cost will decrease. That is one possible chance. Okay, that is one possible chance. So what I am telling is, you enter from line 1 or line 2. Okay, what do? You enter from line 0, assemble the car, you will get one answer. You enter from line 1, okay, you assemble the entire car in the possible options, in possible ways, and you will get the answer. Out of these 2 answers, we will take the minimum. Right? That will decide. That is one option over here. Okay, by entering the line 0, you may get one answer. By entering the line 1, you may get a different answer. So we have to take the minimum of these 2 answers. Okay. Now, after entering, when you will start constructing the car, from station 0, you will start constructing the car. Okay, this is station 0, 1, 2, 3. Right? So if you enter from the line 1, here, this is the first station. Okay, this is 0th station, 1, 2, 3, as per our array concept. Okay, so when you will start manufacturing the car, after you enter the car. So when you are manufacturing a car, what do you need? You need 2 things. One is in which line you are there, and second one is at what station you are. Okay, at what station you are. You can switch to line 2 but the entrance can be from line 1. Okay, you can enter from here, you can complete the job here, and you can transfer to line 2. Okay, that is also one possible option. Okay, whenever you are manufacturing any car, what are the 2 parameters you require? You require in which line you are and at which station you are. These are the 2 important things you needed. So let's write the recursive function initially for this minimum concept. Okay, by entering the line 0, you will get one answer. By entering the line 2, you will get one answer. You have to return minimum of these 2 answers. Okay, so let's remove the previous code. Here int assembly scheduling. Okay, what are the options? Int option 1, we can enter from line 0, but line 0 will have entry cost. E of 0 represents the entry cost, right? Now plus start manufacturing. Okay, from where you will manufacture? If you enter from line 0, you will manufacture from 0th station. Okay, and what is the line? 0th line, 0, 0, right? Okay, 0, 0. Okay, line 0. Okay, E of 0 is line 0's entry cost. Now what is the other option? Option 2 is E of 1. You enter from line 1. and you start manufacturing the car. Okay, start assembling the car, you can tell. Okay, from which line you will start manufacturing? If you enter from line 1, if you enter from line 1, from 0th station you will start manufacturing, means line will be 1 and the station will be 0. So line will be 1 and the station will be 0. So you are entering from line 1. Okay, E of 1 is the entry cost for line 1. So what you are going to return? Return minimum. So let's define one macro for that. As define min of a comma b. Okay, a greater than b, ternary operator. If a is greater than b, you return b. Okay, this returns the minimum. This is ternary operator. Okay, now what you are going to do? Return minimum of option 1 comma option 2. Okay, this is one thing. Now let's write the start manufacturing recursive program. Now here int start. Okay, let's copy int line comma int station. Now here we have two options. Either we do the job at, okay, here we have two options. One is after completing the job at particular station, we can forward the job to next station in the same line, or you can forward the job to next station in the below line. Okay, in the other line. Once the engine is fitted, you can transfer the job for body fitting in the same line to the next station, or you can transfer for body fitting to the other line. Okay, so we are left with two options. So while transferring the job from engine fitting to body fitting, if it is in the same line, there is no extra cost. But if you are transferring to other line, there is an extra cost that you have to consider. Okay, so let's write those two options. Int option 1, if you are manufacturing the car in the same line, then you just transfer the job to next line, next station. So in the same line you are transferring the job to next station plus 1. So no extra cost is needed. So if you are transferring the job to other line, okay, when you are transferring the job to other line, so you are transferring job from S00 to S11. So there is an extra cost T of 0, 1. Okay, plus, and you are transferring the job to this particular station. So you have to write that. So T of line, comma, you are passing it to the next station plus 1. Okay, diagonally you are passing the job, plus that you are adding the cost, and you are asking what is the manufacturing cost from this line. Okay, here whenever you are passing, if line is equal to 0, okay, if let me complete this. 1 minus line comma station plus 1. So 1 minus line comma station plus 1. So consider if line is equal to 0. So in this option you are passing to the other line, right? From now you are passing to other line. So from 0 to line 1 you are passing. So 1 minus 0 gives you the line number, which is 1. So if you are passing from first line to 0th line, okay, 1 minus 1 means 0. So you are passing it to line 0. That's why I have written 1 minus line. Okay, no confusion in that. Shall I repeat? Okay, from 0th line you are passing it to line 1. Okay, from this line you are passing the job to line 1. So 1 minus line. So current state, the line is 0. So 1 minus 0 is 1. So the job is passed to line 1 to station 1. Okay. If you are passing the job from here to here, so current state line is 1. So 1 minus 1 is 0. So line 0 comma station 2. For station 2 you are passing the job. Okay, got it. But there is an extra cost T of 1 comma 2 that you are adding it. So this is the thing. So T of line of station plus 1 plus 1 minus line comma station plus 1 to the next station you are passing. So these are the two options that you are calculating. Now just think like this. So you have fitted the engine here. So you have two options, either passing straight or passing to second line. Just imagine, by passing straight you got one answer. By passing to second line you got one answer. By passing straight the cost is calculated as 100. By passing to second line the cost is calculated as 75. So you got two options, two choices, two costs. So what you have to pick? You have to pick the minimum cost. Okay, you have to pick the minimum cost. So whenever you got two options, you have to pick the minimum of these two costs. So what do? You will pick the minimum of option 1 comma option 2, and also there is a cost associated at this particular station. Okay, so what you are doing is you are trying to calculate the minimum of this cost and try to calculate the minimum of this cost. Okay, you got by going straight cost is 100, by going to different line the cost is 75. Out of these two you are picking 75. Okay, again here there is one more cost. So at this particular station 4 unit cost is occurred. Okay, you have to add this 4 units to the minimum of these two costs, right? You understand? So what you are doing is you are calculating by going straight way. By going in a straight line you are calculating cost as 100. By going to other line and going straight you are calculating cost as 75. So out of these two you will pick the minimum, which is 75. And at the current station over here there is an additional cost of 4 units. You have to add that 4 units to the minimum of these two options. Okay, so let's add that one also. So you are calculating minimum of that and you are adding the cost at that particular line and at that particular station. What is the cost that has occurred? You are adding it and you are returning that one. Okay, now we have to write the base condition. What is the base condition? So whenever you have reached the last station, polishing station, what you have to do? You have to exit from here. Okay, so while exiting there is one more cost, exit cost. So what you have to do? While exiting there is no option for transferring and all. Okay, so you have to add the cost at this particular station plus you have to add the additional cost and return. Okay, so how do you know what is the last station? Based on the index. Okay, when the station is equal to, we have defined stations as 4. So here when the station index is 3, which is nothing but stations minus 1. Okay, because of this arrays concept, zero index concept. So as this is 3, when the stations minus 1 is equal to 3, we just do, what we do is we add the cost at this particular station plus exit cost, we return it. Okay, now so here we have defined it. So number of stations as 4, and here the variable is there, station. If station is equal to stations minus 1, okay, then we have reached the last station. What do we do now? We just add what is the cost at that particular station plus now exit cost. Exit cost is based on the line. right? Different lines have different exit cost, so we just return a of line of station plus exit cost of that particular line. So this is the base condition, right? Now let's run and try to find the answer. So 35 is the minimum cost for manufacturing a car with the given inputs. Okay, now let's try to increase the number of stations. So I have added 40 stations like this now. Okay, when we give 40 stations, we know we won't get the answer because of the overlapping subproblems issue. Okay, so we have to apply our caching technique. So what do we do? So we have to define a cache. So here two variables are changing, line and station. So 2D cache is enough. So, and I will mention in the program that I won't give more than 10 lines. Okay, there can be multiple assembly lines. Okay, here you have seen only 2 lines, but I can, in the program I may, in the input I may mention, I can give till 10 lines. So you need 10 plus 1 11. Okay, 11, and number of stations won't be greater than or equal to 100. Okay, if number of stations won't be greater than or equal to 100, then you have to define a cache like this. Okay, based on the inputs that we mentioned in the program, you have to define the cache. Okay, there can be a number of test cases. One test case can have only 2 lines and 4 stations. Other test case can have 10 lines and 100 stations, and one more test case can have 6 lines and 32 stations. Like that, it can vary. So for each test case, you have to reset the cache and try to execute it. So this is the part of competitive programming. Okay, now let's init the cache. Init cache. Okay, for int I is equal to 0, I less than 11, I plus plus. For int j is equal to 0, j less than 101, j plus plus, and define the cache of I of j is equal to -1. Okay, you are defining nothing is there in the cache. Now what do you do? Whenever you are returning, you just store that value. You just store the line and station state into the cache before returning it. So after that, what do we do? If again if it asks to calculate, okay, you just check in the cache if for that particular line and station state, if the value is not equal to -1 in the cache, you just return from the cache. You don't recur further. Okay, if we try to run this program, we'll get the answer in few milliseconds. Okay, let's run it. So we got an answer as 10. So something we have messed up. So what did we do? We didn't init the cache. We have to init the cache before calling the calculation. Okay, now if we run, we'll get the right answer. Okay, we have to init the cache before calling the program. Okay, now what is the answer? It takes, okay, so 160 is the minimum cost for scheduling a car. Okay, I hope you guys understood, right? Fine. So the program explained in this video, you can find the code in the description of the video. Okay, see you in the next video. Bye, have a nice day.